Hello everyone. Welcome to the remote knowledge session. I hope all of you are doing well and staying safe at your places. Uh, so, I, Yamini Bansal, will be taking an introductory session on Amazon SQS. So, let's get started. First thing first, let's walk through the remote knowledge etiquettes. We should respect the knowledge session timing and not join the session 5 minutes past the session start time. Keep yourself on mute unless you have some queries or doubts. Don't forget to leave a constructive feedback as it will be very helpful for the presenter to present better next time. Yep. So the agenda comprises of what is a messaging queue, when and why we need a messaging queue, what are the available options. There are a ton of options available. We'll see how we use Amazon's SQS, and there will be a short demo on it. So, message queue, what are they really? So, message queue is a mechanism which we use for synchronous or asynchronous communication between distributed components. So let's set a background here. Uh, when we have developing an application, we should have clear, may not be exact, but fair enough idea about how its architecture is going to look like. Starting with small scale application, and after the recognition or high demand, we may like to scale and distribute our application. So when we think of our application being scalable and distributed at some point in time, we must also consider the fact that it is going to face component failure, we can say service failure, or unavailability of a particular component. So to take care of these issues, we employ message queue. There could be many other options for these kind of issues, maybe circuit breaker, retries, etc. But I'm going to talk about message queue. So message queue, just like I said, is a mechanism used for inter-application as well as intra-application communication. Message queue can be synchronous as well as asynchronous. With asynchronous, I mean that when the producer component does not block its resources for the response of the message, or it just carries on with other tasks and not wait for the response, is the asynchronous message queue. And the synchronous message queue is when the producer or the sender component waits until its message is processed by the consumer or the recipient component. Yeah. So async message queue help us decouple our distributed components, or we can say services in microservice architecture, along with reliability and scalability. So it also provides message persistence. You may notice an asterisk here. I will talk about this asterisk when talking about the SQS, right? So let's move on. Now the question comes, when we need message queue, right? When we have a distributed application, the communication between services need to be reliable and non-blocking, so that if the recipient component is down or under maintenance or unavailable due to any reason, and it is not available to process the message or the request made to that component, to keep those messages or requests, we need message queue, right? Now you may ask, why only message queue? Okay. Yes. So there are some quality features, or you can say some features associated with message queue that I'm going to list down now are reliability. Reliability, as in we could take care of the dead letters. Here, by dead letter, I mean unprocessed letters, which might get left unprocessed or unnoticed by the service, which goes up and running after failure or maintenance. Okay. So message stays in the queue unless it is being deleted by the recipient or get deleted automatically by the timeout. Other feature is high availability for better performance. So saving the queue on multiple servers to provide highly concurrent access to messages is another key feature, so that our we do not have a two service application. We have many services in our application. So to let them work concurrently, we there is a factor of high availability. So saving the queue on multiple servers saves us from this. And next is the delivery of a message. We have two types of delivery, at least once delivery or exactly once delivery. So what are these? We're going to cover it in the SQS. And the other is customization of message queue according to the data. So customization contains our message may not be of the definite format because the data can be unstructured. So we can customize our message queue according to the data coming. And yes, we can customize these message queues according to the need. So next comes the available options. For available options, we have Amazon SQS, some other options like Apache ActiveMQ, Apache Kafka, RabbitMQ. So, and there are two implementation of message queue in Unix are via sysv API and POSIX for inter-process communication. So we have these many and many more options available. So looking at this slide, maybe you have any question like what is the difference between Kafka and SQS, as we at Naldus use Kafka a lot and we are familiar with that. So anybody having any question? Yeah.
Just one question, Yamini. From the overall cost perspective as well, in terms of or the effort perspective, which one is have you prioritized it basis the effectiveness, or is it basis easy implementation, or so how we can if you just had to look at that, if you could just sort of provide some inputs there as well in case if you had research on those aspects.
Okay. So Atul, the order here is not according to any perspective like cost or the implementation easy to implement. It's just a random order. So if we talk about Kafka, Kafka is an open source platform which is a message broker, and Amazon SQS is a message queue service. But yeah, here one big factor is this: since Kafka does not cost us anything, but Amazon SQS cost us for um, every single request after a particular specified threshold per second, number of requests per second. So yeah, if our application uses a lot of AWS products and to have basically a better compatibility, we use Amazon SQS, and it is very easy to use, user friendly. Yes. Yeah.
Okay, so would it be appropriate to say or conclude that only application that use the Amazon AWS kind of an ecosystem, their Amazon SQS is recommendable versus and for the others we can go for the other open source options available. Is it?
Yeah, it is because it is more recommendable if our applications ecosystem uses more of AWS products, then it goes well with that. And whereas Apache Kafka does not have any influence to other services or products we are using, it's just a simple software platform. Oh, sorry, a streaming platform. Yeah.
All right, thanks, Yamini. Just on this, since you're on this slide, I mean, I'm curious to know if, from an effort and effectiveness perspective, like less effort and more effective, out of the rest of these MQ solutions that are available, which one is obviously we are using Kafka, a lot, but in our experience, uh, is there anything that is more recommendable out of these given options? Just out of curiosity, anyone, I mean, Yavni, you or anyone in the group.
Asking for recommendation, I like we cannot straightforward recommend this without looking at the architecture or looking at what kind of application we are having at hand. So I don't have a particular say here that you should go for Amazon SQS because it is for XYZ reason, and or you should go for Kafka for ABC reason. So we cannot make a decision unless we have a structure or architecture of an application in mind, what services it is going to use, and the compatibility and the user friendliness. All these factors goes hand in hand. So you can look at it.
Great, Yamini. Thanks much. Please
Yeah.
go ahead.
Any other questions? Anybody? Okay. So let's move to the next slide. Yeah. So as the topic of today's session, the introduction. So let's have an introduction to Amazon SQS. Amazon SQS is a simple queue service provided by Amazon. Uh, it offers secure, durable, and available hosted queue. So secure, durable, and available hosted queue. So with secure, we mean that uh, we can save our messages from outside world with encryption. So security is covered. Durability. The when we store a message to a queue, it gets stored to multiple, or you can say redundant architecture infrastructure to provide us better durability. If one server goes down with the queue, then we still have some other replicas of it. And available hosted queue is the same thing, that it is being hosted by the Amazon. So it lets us integrate and decouple distributed software components and systems. So decouple and integrate, with this we mean that let's say two services tries to communicate with each other, but the receiving service goes down, right? So what would this the sending or the producer service do? We have some options like, is it going to wait until it gets the response, or it retries after a specified amount of time, or it just carries on with its work without caring about what's the result. So decoupling comes here that we do not want our producer service to keep waiting for the result, for the response of a message. It just saves, it just send the message to the queue. The queue holds it until it is get processed, and the response can be given to the producer when the consumer service processes that message. Okay. So next thing is it provides a web service API, and it can be accessed by any programming language that AWS SDK supports. So there are a lot of languages that AWS SDK supports. So we have a demo for Scala in Scala. So we'll look at it later. So yeah, so it supports two kinds of queues, standard and FIFO. So with standard, the delivery type of messages is at least once delivery. So what do we mean by at least once delivery? That in the queue we can have redundant messages. Right? Uh, if a message is sent by the producer, uh, but after a particular time it does not gets the response, it resends the message. So in a standard queue, a standard queue may have redundant messages, but the if talking about FIFO, it can have exactly one message, no duplicate message in the queue, and it will be processed in the same order it is placed in the queue. So in the FIFO queue, the sequence of the messages uh, remain same as they are input to it and gets processed in the same order, which is not true for standard queue, as the order of messages may get disturbed. So the last thing is it offers constructs such as dead letter queue. So dead letter queue plays an important role here. So we are talking about failure of or the under maintenance of a service a lot. So during that period, the producer is not aware that the recipient is under maintenance or having some kind of failure. So when the producer service realizes that after this much time I'm not receiving response to a request, a message, then it places these messages to dead letter queues. So we have standard dead letter queues as well as FIFO dead letter queues. So whenever we will be having a standard queue, with that goes the standard dead letter queue. And similarly for FIFO, if we are having a FIFO queue, we'll be having a FIFO dead letter queue. So next is the life cycle of Amazon SQS message in a queue. So as the picture says, component 1 produces a message and it gets placed into the queue, right? Whenever component 2 is available to process a message, it will fetch the message from the queue, and we have this visibility timer. So the asterisk I talked about, the message persistence. So there are two things to consider. First, the visibility timer to avoid multiple times processing of a message, so that a single message does not get processed more than once. So for that reason, we have a visibility timer here. And the second thing about the message persistence, let's say a component 2 processes message A but do not delete or remove it from the queue. So what happens to that message? Will it remain in the queue for forever? No. So the persistence does not mean that it will remain in the queue forever, but the persistence here also is measured for, like, it talking about the default persistence time is 4 days, but we can change it from 30 seconds to 14 days converted to seconds. Yeah. Whatever will be the value of 14 days in seconds, right? So this is what Amazon SQS is all about, and it is a very user friendly queue service to, and very easy to use. So let's have a demo about.
I have a question, Yami. Sorry to
Yes.
interrupt.
Yeah.
So, the maximum, if we do not delete the SQS, like message in the SQS queue, like, like the maximum duration it can bear that message in the queue is 14 days, right?
Yes. Yes.
And if we do not delete it, it will automatically remove it from the queue.
Yes.
Okay. Cool.
Okay. That's so let's go for the demo. So for the before starting with the demo, we need to have some things set up here. So first of all, one would be needing an AWS account with IAM user, IAM user, and with that you will get some key and ID. So I have made a copy of credentials here. So yeah. So this you will be needing to add your access key ID here and access key here from the IAM user. You need to save that and put it here, or you can also import it as system variables, environment variables, and you need to set the region for where your service is hosted. All right. If you don't add this or the particular region you are using, it will automatically use this as the region. Okay, let's move forward. Also, you would need to have Amazon SDK installed on your machine or the server where the services are running. So, yeah, I have here I have created two APIs. One to when we'll get a post request with some data, it will put that data to the queue. All right. Uh, and the other API to retrieve the data and delete it from the queue. After it processes and we see some kind of output here, we'll put it, remove it from the queue. All right. So let's run both of the APIs. Yes, so both of them are now running. I will send the post request with some data. Let's see. And we'll see that what it returns. Okay, so we see that we receive a JSON with with ID 0 and name, etc. So what I did in this API is I've created a route for post request, and we are just sending the message to SQS. Right? So how do we send this message to SQS? Uh, we just need to create Amazon client builder. Client builder with default client means it will take the default values from the config and the credential files that I shown you earlier. And I have mentioned a queue name with the method call, and we have the queue name will be as you can see here. The queue name is YB testing. Okay. So I have it created one. It get one message from the API. Now we'll try and remove one message, and we'll see which message it removes. So in retrieve, we get some other message which is 18. You may not know the sequence of the message it receives, and because the default type of queue is the standard queue in which the order of the messages is not retained. So yeah, if we again go to this, and we'll see that one message is being removed now. Yeah. So this is how we do things here with Amazon SQS. So this is the saving the message as well as retrieving a message. As you can see, I have typecasted it, converted it to my case class. So you can see that I have used a case class employee here, and when using the retrieve message, we have fetch message, and we are converting it again to the case class, and I'm printing it via the parameters of the case class. And you can do whatever we want to do, like saving it to the DB, or based on the message sending another request, or sending some response, or fetching anything from the data. We can do n number of things. Also, it's not like that we can only have some case class, only a single case class. We can also have a mapping of objects stored uh, in the queue, like a mapping from message type. Let's say we have a message type, whether this message is going to contain an employee or a user. So based on the first value of the JSON, which is the message type, if we get employee, so we can convert it to employee. The second parameter of the JSON will be a JSON. And if the message type is user, we can then convert the JSON to the user. So yes, that was the all about Amazon SQS, and I think we have 10 minutes for Q&A. Anybody having any questions now? Any questions?
So it's a simple queue service, right? So whenever
Yes.
I will ask a message from SQS, it is going to return me one message at a time, right?
No,
Mhm.
not one message at a time. It's basically depends upon the polling. It uses a scheduler polling, which has a default size of 10 messages at a time. So whenever you try retrieving messages from it, it will return you 10 messages. If your queue contains uh, basically a lot of messages, then 10. So only then it will be going to return you based on the polling quantity you are setting. So since my queue was having exactly 10 messages, so it will definitely going to retrieve less amount of messages.
Okay. Okay.
Yeah.
So basically, what you are saying is that it gives you a message uh, in the batches,
Batch.
right? In the
Yeah. Yeah.
batches.
Yes.
And so basically, is there a failure handling? So let's say I got a message, right, and if I didn't send an acknowledgement, then what will happen?
Uh, who didn't send the acknowledgement? Here,
The consumer.
the consumer didn't send the response back to the producer, you are saying.
Yes, back to the queue that I have successfully processed it.
Okay, if it does not send response back to the queue, it does not matter for the queue whether it gets the response or not. It matters for the producer who sent that message, whether I get the response for the request I made or not, right?
Uh-huh. But if
So,
I didn't send an acknowledgement, right, then that message
yes.
is lost. That's what you're saying.
No, the message will not be lost. It will be the producer's responsibility to have this kind of provision that if I do not get response of a particular message, I need to put it into the dead letter queue so that whenever we'll be having a maintenance or overlooking the failures, we would look at which messages were not being able to process so that they can be retrieved later and processed by the consumer later.
No, no. So basically, there are two things, right? One is producer, one is the consumer. Okay.
Yes.
So producer is sending a message, right? And then SQS will acknowledge whether SQS has received that message or not, right?
Yes.
Because it's a
Yes.
async queue, right? So it
Yeah.
cannot wait for your consumer to respond, right? It has no link. Producer doesn't know which the consumer is,
Yes.
right? So
Yes.
so basically, when you are sending a message, Yamini, then the message will go to the queue, right? And
Yes.
if the message has not gone to the queue, right, it or basically it is not able to successfully process that message, right, then SQS will put it in a dead letter queue,
Okay.
right? I think that is how it should happen, right? Now, what I understand from SQS is that once you have read the message, right, it is deleted from the queue. So based on my understanding, okay, I am not sure, but that is how SQS work, right? So as soon as you read the message, so there is, let's say there is only one consumer, okay, so as soon as
Yes.
you read that message, right, and
Yes.
then the message will be deleted from the queue.
No, that is not the case.
That is
Uh,
not the case. Okay.
no. If you only read a message, I mean, you process a message and you do not, the consumer do not removes it from the queue, it will not get deleted until the timeout.
Okay.
A timeout for persistence in queue.
Okay, so it will be in the queue, and then we can read. Then the consumer can read it again.
Yes, it will be visible after the. There are two things. One
Mhm.
is message persistence, and the other is the message visibility. For the time the message is being processed by a single consumer, it will not be visible to others. And as and when the a consumer is finished processing that message, it will be visible to others if it not has been deleted yet.
Okay, but if it has been deleted, then it will not be visible to other consumers.
Yeah, obviously, yeah.
And then so basically let's say then this message, right, will be visible to the consumer who has consumed it, or it will not be visible to it again.
No, to all the consumers, if it has the time for persistence and the visibility timeout is over, it will be visible to all without any exception.
Without any, so I can basically process that message again and again, the same
Mm,
consumer.
yeah, this is the question. I need to check. Yeah,
Okay, okay, sure, Yami.
I will
Yeah,
get back to you later. Yeah.
yeah, because there should be some mechanism for SQS to know whether that particular message has been consumed by consumer or not. Because
Yeah.
if consumer has not removed that message after processing, in that case, that message will be like consumed by that consumer again and again, and we do not want
Yeah.
that.
Yes.
Right.
Yes.
So I'm just trying to map it to. So I know it is different from Kafka. Okay,
Yes.
because I think Kinesis and Kafka are more parallel rather than SQS and Kafka. Okay, so
Yes.
so basically, does it maintain any kind of consumer offsets? Okay, so that is the question that I wanted to ask, because
Yeah.
a queue can have many listeners, right? So
Yes. With this question, I'll get back to you.
sure, sure. Thanks, Yam.
I have one more question. I think there are other messaging services as well, right? In Amazon, like SNS, etc. So how this SQS is different, with those kind of services,
Uh, Amazon SNS, I think, works on the topic subscription. I think I haven't been able to get to know that, but I think it's more of a publisher subscriber thing. And unlike SQS, it has topics for that, for consumers to subscribe to, so that they can consume from the particular topic. And it is more, SNS is more of uh, having SNS is having more functions than SQS, because uh, it is going to be, how do we say that, like it gets to know the data, that if this data is coming, I need to put it into this channel or in this topic. Whereas SQS does not have this thing. It's just a data structure queue. Yeah.
So basically, Atul, what is happening is the SQS is a simple queue. Okay, so 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 basically it works in the model of first in first out, right? So basically it is SNS is have more richer functionality. Okay, so SNS is primarily used for notifications, right? So you can hook up your notification services like SMS, okay, or basically your emails and all those things, okay, to
Okay.
SNS. Okay, so SNS has a richer interface that is provided by Amazon. Actually, both SQS and SNS, right? So they are not good for your real-time streaming data. Okay, so that's why they have. So actually, Amazon has three systems, right? One is Amazon Kinesis, another is Amazon SQS, and one is Amazon SNS. So SNS is more used from the notification perspective. Okay, SQS is merely used, right, where you want to, so where you want a simple queue, right, that you want to process message one by one, okay, or in batches, right, and there is a simple logic behind that. And for real-time streaming, right, you have to use Kinesis.
Okay. Okay, makes sense. Thanks, Bhavya, and thanks, Yamini, as well.
Thank you. Any other questions? Okay. So